In this first final exam problem, we were tasked with writing the lexer for a new programming language. There are 7 types of tokens, and 4 of which are simple operators. We have plus, minus, times, and divide. So here I've written the token rule for the plus operator. The first line is a regular expression that matches the plus symbol, and then we return the token unchanged. And for the rest of the operators, we're going to follow that same format. We're just going to change the name of the function, and we're going to change the symbol to which it matches. Our next token is the identifier. In our programming language, this will be the names that we have for things. So it can be something like my underscore variable, or something even more interesting, like just the word Andy. More precisely, in our programming language, an identifier is a non-empty sequence of letters and underscores where the first character is not an underscore. So we can write our rule for that pretty simply. Here I have a function, t underscore ident, and the regular expression is pretty simple. The first character, and it has to be at least one character because it's a non-empty string, is just going to be some letter. And then we're going to be followed by 0 or more letters or underscores. So strings in this language are very similar to strings in Python. We can have single or double quotes, but in this particular language, for which we're designing our lexer, we don't have any escape sequences. This actually makes the expression to match these strings much simpler. So the first rule I'm writing is just for single quoted strings. The rule for double quoted strings is going to be very similar. It's just that the regular expression to which we're matching is going to be slightly different. When I go over the code at the end and I show you the finished product, I'll show you what that looks like. But for now, let's just concentrate on single quoted strings. Here I require that the string begins and ends with a single quote and is a sequence of 0 or more, we can have an empty string, characters that aren't the single quote. Since we don't have escape characters, that's all we need. So here I'm taking out the quotes from the beginning and end of the string. That way the value of this token is the string itself, and I'm setting the type to string, all caps. Numbers in this language are a little bit different than Python. First off, the only numbers we have are positive integers. So -5 and 5.5 are both not valid numbers in this language. So one example of a good one would be 5. We're also allowed to put underscores anywhere in the number as long as it's not the first character in the number. So 5 underscore 5 triple underscore is going to be equivalent to just 55. A lot of languages actually have this feature because it's easier to read 1, 2, 3 underscore 4, 5, 6, similar to how we often put 123,456. So here I've started writing out the token rule for numbers in this language. The first character has to be a digit, 0 through 9, and afterwards we can have 0 or more digits or underscores. Now we want the value of the number token to be the number, the integer, that it represents. However, if we just return the string or try to call some integer conversion on it, we're just going to get a lot of underscores and it's not really going to work, and it's not what we want. We want to take 5 underscore 5 triple underscore and just get 55. So my strategy is going to be to go through each character in our string, append any digits to a new string, ignore any underscores, and once I'm done, call int onto that string to get the integer that the original token represented. So here I have the finished function. I'm going to go through each character like I planned. If it's not an underscore, I'm going to append it onto our temp string and then call int on that temp string to get the new value. And here I have the finished code. We have our basic operators, plus, minus, times, and divide, the identifier function we wrote, single and double strings. Really the only difference here is that we have single quotes right here and double quotes right there. And lastly, the number token function that we wrote.